First thing we do when calculating an improper integral is turn it into a proper integral. And so we'll go from 0 to b of e to the negative x over 4 dx. And to compensate for that, we're going to take the limit as b goes to infinity. A lot of times you'll see us use b for the upper limit, a for the lower, when we have to substitute that one. Now our goal is to ignore this, and we focus on this integral here, which if we want, we could use a u substitution. I'm going to let u equal negative x over 4, and then du equals negative 1/4 dx. Well, I don't have a negative 1/4 in there, so I'm going to put a negative 1/4 in my integral for my substitution. And outside here, I'm going to write it all the way out in front of the limit. I'm going to put a minus 4 to compensate. Those are going to cancel each other out. So I have minus 4 times the limit as b goes to infinity. Now one of the things that I can do here is I can change the limit so I don't have to substitute back. I know this is going to be e to the u du. Right there is exactly my du. These are x values. If I plug 0 in for x, I still get 0 for u. If I plug b in for x, I get negative b over 4, and you'll see how that plays out when we sub it back in. Now, we get a very easy antiderivative. So we're going to have minus 4 limit as b goes to infinity. The antiderivative of e to the u is just itself. I don't have to substitute back because I changed my limits. And so in my next step, I'll plug those in, and then we'll take the limit, and we will see if this guy converges or diverges. So I have e to the minus b over 4 minus e to the 0. So I still end up with the negative in the exponent that I had before. So as b goes to infinity, e to the negative b over 4 is going to go to 0. That's our decreasing exponential function. So what I get is negative 4. Now here, be careful. A lot of people always do this as 0. E to the 0 is 1. So taking that limit, my limit is done, and I end up with a negative 1 there. So my final answer for this one is 4. So this one converges to 4.